Assalamualaikum girls. I am Shamsunisa from Royal Degree College, Chemistry Department. As we are talking about Unit 2 Organic Chemistry, in that today we will start second chapter, that is heterocyclic compounds. In this we are seeing the introduction, nomenclature and aromatic character. Introduction of the heterocyclic compounds. So heterocyclic compounds are those cyclic compounds in which one or more of the ring carbons are replaced by another atom. The non-carbon atoms in such rings, other than carbon atoms, in those rings are referred to as heteroatoms. The most common heteroatoms are nitrogen, oxygen and sulfur. Nomenclature. The common names of some of the most important 5 and 6-membered heterocyclic ring compounds are, see here the 5-membered ring compounds. One is furan, in which heteroatom is oxygen. In thiophene, heteroatom is sulfur. In case of pyrrole, heteroatom is nitrogen. And in case of indole, here also the heteroatom is nitrogen. Next is 6-membered ring. One example is pyridine, in which the heteroatom is nitrogen, and another one is quinoline, heteroatom is nitrogen. Here in case of the quinoline, which is a 6-membered ring, how we are giving the numbers to the ring, the nitrogen where it is present, that is the first position, then this one second, third, fourth, fifth, sixth. Okay, 6-membered ring with the heteroatom nitrogen is getting attached with the benzene ring named as quinoline. And if the heteroatom nitrogen in the quinoline, if it is changing its position, okay, at that time it is named as isoquinoline. So here, wherever the nitrogen is attached in the ring, that will be the first position. Here, listen, this is the first, this one is the second, third, fourth, fifth, sixth. Okay, but what is the difference between the quinoline and isoquinoline? The position of the nitrogen is being changed here, that you can see. Rings containing nitrogen usually end with OL. Okay, if 5-membered, look at this again. OLE, you can see here indole. It is a 5-membered ring compound which is being attached with the benzene. OLE. And another one is, if the 6-membered ring compound is there, it is named as INE. That is, you can see here pyridine, quinoline, isoquinoline, like that. Now we'll see about the aromatic character. Pyrrole, furan and thiophene are aromatic in nature, like benzene. These are unsaturated compounds. They show substitution reactions. 5-membered heterocyclic compounds follow Huckel rule. So according to this particular Huckel rule, they possess 4n plus 2 pi electrons and show aromatic sextate. So the resonance structure of furan can be represented as, here you can see the resonating structures of the furan. That is, which is a 5-membered ring compound, we all know this. Okay, in that heteroatom is oxygen. On the oxygen you can see the lone pair of electrons. The 2 lone pair of electrons are present on the oxygen. So what is happening here? One of the lone pair of electrons sharing and pairing and forming a bond in between oxygen and carbon. Okay, here we are getting double pair. As the electrons are shifted towards this side, so oxygen is carrying a positive charge because of the electron deficiency. At the same time, from this side, the one of the bond it is coming outside the ring, and here we are representing in the second structure as the electron pair outside the ring. Okay, this is the first resonating structure. From this, we are getting the second resonating structure. How? This pair of electron, it is being introduced inside the ring and it is forming a double bond. Okay. And at the same time, here you can see in the third structure double bond here. And at the same time, one of the bond from this side is going to attach outside the ring and it is attaching as the two electrons like that. We are representing with the two electrons and rest of the things are as it is. Now we are getting this resonating structure. Then from this resonating structure, we can get the another structure. How? These electron pairs sharing and pairing and forming a bond inside the ring in between oxygen and carbon. Here you can see. Okay. And that at the same time, double bond is there here. Na? So one of the bond it is coming outside and it is represented as the pair of electron outside the ring here in this resonating structure. Okay. Then what will happen? This electron pair which is present outside the ring, it is going inside the ring and forming a double bond here. So here we are getting double bond. And at the same time here double bond is there na, at this position. It is coming outside the ring and we are representing as the pair of electrons. This resonating structure we are getting. Okay. Then from this structure again we are getting back our first structure. How? See here, pair of electron, it is present outside the ring, it is going inside the ring and we are getting a double bond here. You can see double bond. Then here double bond is present. This double bond, it is going towards the oxygen and we are representing a pair of electrons on the oxygen. So like this structure we are getting. That is the first structure we are getting back. Here stabilization of uran is 16 kilocalories per mole. Now we are seeing the resonating structure of pyrrole. It can be represented as, in case of pyrrole, heteroatom is nitrogen, which is also a 5-membered ring compound, isn't it? So here on the nitrogen pair of electron is present and along with the nitrogen here you have to represent the one bond with hydrogen. Okay. So what will happen here, as the pair of electron is present on the nitrogen, it is sharing and pairing and forming a bond towards this side. Means in between nitrogen and carbon, double bond is going to be formed. Here you can see. When the bond is shifted towards this side, nitrogen is showing the electron deficiency, so it is carrying a positive charge. And at the same time, here double bond is there. Now one bond it is coming outside the ring and we are representing in the next structure as the electron pair outside the ring with the negative charge because of excess of electron. Then from this structure we are getting the next resonating structure. How? This pair of electrons, it is moving inside the ring and we are getting a double bond over here. Then at the same time here double bond is there. Now one of the bond again it is coming outside the ring and we are representing that one with the electron pair and excess of electrons, so the negative charge on that. Then from this resonating structure we are getting the another structure. How? This pair of electron, it is again sharing and pairing and forming a bond inside the ring in between the nitrogen and carbon. At the same time, this double bond is there. Now it is coming outside the ring and here in the next structure we are representing the two electrons with the negative charge outside the ring. Then from this resonating structure we are getting the another resonating structure. How? See here, the electron pair which is present outside the ring, it is being shifted inside the ring and we are getting a double bond here in the next structure. Okay. And at the same time, at this position double bond is there. Now one of the bond it is shifted towards this side and this side we are getting an electron pair with the negative charge. Then girls, listen this point again very carefully. Here as we are getting this resonating structure, now with the help of this resonating structure we are getting back the first resonating structure. How? See here, the electron pair, it is sharing and pairing and forming a bond inside the ring. Here you are getting a double bond as you can see in the first structure. Then at the same time, here bond is there now in between nitrogen and carbon. One of the bond it is being shifted on the nitrogen and we are representing a pair of electrons on the nitrogen again. So these are the resonating structures, okay, of pyrrole. Here stabilization energy of pyrrole is 16 kilocalories per mole. Next we will see the resonance structure of thiophene. It can be represented as, here we know that here the thiophene, it is also a 5-membered ring compound in which the heteroatom is sulfur. See here you can see in the ring on the sulfur a pair of electron is present, that is lone pair of electron is present. Where the sulfur is present in the ring, that position is called the first position. Then second position. You can see here third position, fourth position and fifth position. Now what will happen here, as the lone pair of electrons are present on the sulfur, it is it is being shifted towards this side, means in between sulfur and carbon we are getting a double bond, as they are sharing and pairing and forming a bond. And at the same time here double bond is present, that one of the bond it is shifted outside the ring, and we are representing here a pair of electron with the negative charge because of excess of electron. From this resonating structure, we are getting the another structure. How? These electrons sharing and pairing and forming a bond inside the ring like this, double bond. And at the same time, here double bond is there. Now, one of the bond it is shifted outside the ring, and here we are representing pair of electrons with the negative charge. Okay. From this resonating structure, again we are getting the another resonating structure. This electron pair, it is being sharing and pairing and forming a bond. It is going inside the ring, and we are getting here in the next structure double bond. Okay, and at the same time here double bond is there. Now this double bond it is coming outside the ring, and here we are representing a pair of electrons with the negative charge. And in all the cases, the sulfur will show the positive charge because of electron deficiency. Okay, then next structure from this we have, what we are getting is the electron pair, it is present outside the ring. Now it is sharing and pairing and forming a bond inside the ring. So here we are getting double bond, and at the same time here upper side double bond is there. Now one of the bond it is shifted outside the ring. Here we are representing that one with the electron pair with the negative charge. See, as we are getting this last resonating structure, now from this again we are getting back the first structure. How? See here, this electron pair sharing and pairing and forming a bond here inside the ring, this side. So that one we are getting back. Then at the same time here double bond is there. Now it is being shifted on the sulfur, and we are representing a pair of electrons on the sulfur, which is nothing but the lone pair of electron. So all these are the resonating structures of whom? Of thiophene. Here the stabilization of thiophene is 11 kilocalories per mole. In the resonance structure of furan, pyrrole and thiophene, partial negative charge is on the ring carbon and the partial positive charge on the heteroatom. The carbon atom behave as electron surplus atom, means electron surplus atom here it is behaving as, and the heteroatom behaves as electron deficient atom, isn't it? Thank you for listening my lecture, girls.